Our second to the last topic is second topic under the heading of statistical inference, or the awesome power of sampling. It is our second definition of the word infer. In this case, in hypothesis testing, it's what can we prove or what can we conclude about the population based upon what we saw in the sample. I've made a few bucks off this and by being an expert witness. A couple people on the faculty have gotten rich by being expert witness in the case, and they use hypothesis testing. What is hypothesis testing? It is a court proceeding. Like our screwed up court system, the statistical court proceedings has a plaintiff. It's referred to as the alternative hypothesis, and has a defendant. It's referred to as the null hypothesis. Whatever we're trying to prove is the alternative hypothesis. We're the plaintiff. I prove I'm right by proving the opposite of what I'm claiming is wrong. It's an indirect proof. I prove I'm right by proving the opposite of what I'm saying is wrong. We have an alpha level. It is an error factor. It is a level of significance, is what it's called. And that is the probability of convicting an innocent person, of convicting a defendant who was in fact telling the truth. So we got a plaintiff. Whatever we're trying to prove is the plaintiff. That's the alternative. Whatever's left is the null hypothesis. All right. That with our little introduction, with our handout, we're ready to roll. Diuretic is president of Herbadeth Products. Di has issued a press release concerning a new weight loss product. The press release claims that the average user lost 15 pounds during the first month. Random sample of 36 individuals using the product showed they lost 13 pounds in the first month with a sample standard deviation of 2. Can it be proved that the manufacturer, that Herbadeth, is not as effective as advertised at the 0.05 level of significance? This product is not as effective as they claim. So we start off as usual. We show what kind of data did we have? What question was asked 36 times? How many pounds did you lose? Can I do arithmetic with the result? Yeah. 15 is 2 more than 13 is 5 less than 20. Okay. Do we know anything about the population, the candidates for this? No. Mu? Nope. Sigma? Never know those. Took a sample of 36, found the average weight loss was 13 pounds with a sample standard deviation of 6. What are we trying to show? Can it be proved that lard lifter is not as effective as advertised at the 0.05 level of significance? We're trying to show that the average weight loss of all of the users of this product will be less than 15, that claimed by the manufacturer. We are trying to show that they are guilty of false advertising. We're the FDA trying to prove them guilty of false advertising. So that's what you formulate first. Who's the plaintiff? We call that HA for some reason, alternative hypothesis. What are we trying to show? We always specify our argument in terms of mu's or p's. They're in terms of mu's or p's. Trying to show that mu, the average loss of everybody who uses this product, is not 15. I think it's less than 15. What does the manufacturer claim? Well, it's anything that's left is what you do. Anything left, anything that's not less than 15 would be what? Greater than or equal to. That's the manufacturer's claim. So that's what you got to do. You bring to the party, you read the problem, and you say, What are we trying to show? What are we trying to prove? That's the alternative hypothesis. Then you say, what is everything else that's left? That's the null hypothesis. I'm going to prove that I'm right, that HA is right, by proving that HO is wrong. And if we assume this is a true statement, it leads to a statistical contradiction, something that just can't happen by chance. Our level of significance is 0.05. We'll accept a 5% error. It also means we want to be 95% sure we're right before we rule against the defendant. I have yet to be seated on a jury. They say, what do you do for a living? I teach statistics. Peremptory challenge, defense. Peremptory challenge. You get a lot of hung juries because people cannot define reasonable doubt. Reasonable doubt to me, 1 in 10,000. It's less than that. You know, if they fail that test, they're guilty. The end. Okay, 1 in 10,000. All right, so you make these statements. Inside the problem somewhere, it's going to say what your alpha is, 0.05. Then the rest we leave up to our dear and beloved professor, who has provided a wonderful handout on pages 30 and 31. I think it's on page 30 and 31, right? 30 and 31? Okay, good. Wow, this looks like yuck. Another Greek festival going on here. Yeah, all right, okay. If I got to, I must do it. We must. Again, we have 2 sets of formulas, one for quantitative data, one for qualitative data. In this case, we had qualitative data, right? Did we have 1 sample or 2 samples? I had 1 sample of 36. If we're doing our classic research, we have 2 samples, one that gets the placebo, one that gets the treatment or the stimulus. So it's a case 1. Did we sample more than 30? Yes, it's a case 1A. Case 1A. On the final, write down which case you use. So if something goes wrong, I can see where you went off, you know, where it went bad. All right, then we match up of these alternatives. Which one matches ours? Ours was a less than, right? Our alternative was mu was less than 15. You match up on the alternative. All right, here's our case. We got a case 1A2. And here's how we run the hypothesis test. I will reject HO if this is a true statement. All hypothesis tests come down to the following. We say, okay, null hypothesis, defendant, I will give you the benefit of the doubt. I won't require that I see 15 pounds. I won't require I see 14.9, 14.8, 14.7. But there's going to reach a point where that can happen just by chance. And there's going to reach a point where I'm going to call you a liar if it's too far below 15. We measure how too far below is and how many standard deviations you're away from 15. The Z table value is our tolerance. I want to be 95% sure. I'm going to look up a value in the table, and that's my tolerance. I will tolerate that many standard deviations of difference. That's the most extreme number of standard deviations of difference I should see. In our case, it is a 0.05. We just looked up 0.05 and got what? Minus 1.64 or minus 1.65. So our tolerance is our benefit of the doubt is I'll give you 1.65 standard deviations before I call you a liar. And what does z-test? How many standard deviations did I see? So our z alpha is, look up z 0.05, okay? And we look up z 0.05 right here, right there, one of those two, and we get minus 1.64 steps. I will tolerate minus 1.645 standard deviations of difference between what you say and what I see. But anything more than that, I will call you a liar. All right, so then the last thing we do is, how many standard deviations did I see? Each of your 4 cases comes with a z-test formula, which says, for this category of hypothesis tests, how many standard deviations of difference did we see? Here it is. And I transferred that over to here. I plug in my x bar of 13 minus the argued about value of 15. They say it's 15. I saw 13. Divide by s over the square root of n, and that says I am minus 2 standard deviations away from where I should be, under the assumption that they're telling the truth, that the defendant's telling the truth. Our handout said, reject HO if this is a true statement. Is this a true statement? Is minus 2 less than minus 1.64? Yes, it is. Minus 2 is less than minus 1.64. It is more extreme than my tolerance. I'll tolerate minus 1.64. I saw minus 2. I reject HO. I have shown that I am at least 95% sure that the manufacturer's claim is false, that they're guilty of false advertising. Well, what's the last thing I got to do? Well, how sure are we that they're telling the truth or they're lying? What are the probabilities? That's a job for the p-value. The p-value is, what is the chance that they're telling the truth, and what's the chance that they're lying? How do I find the p-value? You go back to wherever you ran your test here. Okay, that's the ground rules for my test. Where I see the symbol alpha, I write p-value. And then I say, put that equal to whatever a z-test I got. So I write z p-value equals minus 2. My z-test was minus 2 standard deviations away. Then you go to your tables and look up minus 2 standard deviations. Minus 2.00 right here. 0.0228. If I said to look up the 0.0228 percentile, you would say walk minus 2 standard deviations away from the center. So that's my little subscript. And set the subscripts equal to each other. P-value equal 0.0228. There's a 0.0228 chance that the manufacturer is telling the truth. But the corollary of that is there's a 0.9772 chance that they are lying, that they are guilty of false advertising. Stop the clock. What was it? 15? We shattered the old record of 2 hours. That's it. You are now card-carrying members of the Hypothesis Testing Club. Not that you want to be in that club, but for the next week, you want to be in that club. All right, so here's the process we went through. I've laid it out here. Step one. I know a lot of you like step-by-step stuff. So read the problem and establish your notation, just like we did for estimation. Then establish HA. Whatever we're trying to prove is HA. State it in terms of a mu or a p. State what you're trying to prove in terms of a mu, the average of everybody, or p, the proportion of everybody. Establish HO. You simply go whatever HA was, take the opposite. Anything left over is HO. The alpha, the level of significance, will be given in the problem. Go to pages 30 and 31 and figure out which case you got. Look up your Z table value. That is the number of standard deviations of difference you will tolerate. The smaller alpha is, the more standard deviations of difference you'll tolerate, the more proof you need. Then you're going to find the Z-test. On the final exam, of course, what will we do? We'll just write the expression for it. We'll take the formulas, just write in our numbers, and then what will our dear and beloved prof do for us? He will give us a check figure for that. Compare the two, make your conclusions, and then I should say number 9, if asked so, ask to find the p-value. Okay, probably should add that. If asked to find the p-value if asked to. All right, welcome, Dano. You don't think you've learned hypothesis testing, but you have. Let us prove it. The student newspaper at a state college, notice I didn't put CSUN in here. I didn't want to get in trouble. I get in trouble all the time anyway. Just published results of a recent student poll concerning a proposal that all locker rooms become co-ed. Whoa. In this poll, 100 students were sampled. 80 said they were in favor of the proposal. The college president, Miss Prudence Righteous, we don't get along too well, quickly ruled against the proposal, claiming that the sample didn't prove beyond a reasonable doubt that a majority of the students in favor of it. In fact, she thinks that a bunch of students who were coming from the MBA mixer were sampled and were inebriated at the time. And so she thinks that they were biased by these MBA students. If a level of significance of 0.05 is used, can the students disprove the president's conclusion? Can the students disprove the president's conclusion? All right, step 1, what do we know? It's qualitative data. Why? What question was asked 100 times? Are you in favor of co-ed locker rooms? Yes or no, yes or no, yes or no. Can I do arithmetic with yeses and nos? No. I don't know how many students we got, like 40,000 now? They're huge. Will we ever know P? No, nobody's ever gonna spend money to poll every student. Grabbed 100 students, 80 out of 100 said yes. What are we trying to show? Trying to show that the majority of students who are in favor of this, that there is a majority of students who favor this proposal. Majority of students is anything over 50%. 50% plus 1 is a majority. So it's, when the word majority came up, and the president said a majority, that's where I got the 50% from. A majority of the students. We're trying to prove a majority of the students are in favor. We're trying to show that the proportion of students across the entire student population exceeds 50%. Everything else is, okay, the null hypothesis is everything else. It's P less than or equal to 50%. Next step, we head to this wonderful handout. It's actually pretty wonderful because it takes what typically takes 3 weeks in a normal statistics class at least, and it lets us do it in 45 minutes or so, including examples. We got a case of number 3, qualitative data. 1 sample. I got a 3A. We sampled over 30. Sampled 100. I got a 3A. I got a 3A. And then we get the direction of the alternative. We're trying to show something's bigger than some value. So we are trying to, that's our case. It is a 3A3. Here's our 2 values. Here's the table value we look up. We look up Z1 minus alpha. 1 minus 0.05 be Z0.95. And that would be plus 1.65 or 4. And then here's our calculated value of the difference between what we saw and what the president claimed. And here's the formula for how to get it, this ugly thing here. Well, we just have to plug in those numbers and then we'll have our check figure to make our conclusion with. So transferring all that stuff over to this page. It's a case 3A3. We will reject HO if Z test is greater than Z1 minus alpha. Our alpha is 0.95. 1 minus 0.95 is 1 minus 0.05 is 0.95. Find me the 95th percentile in the table, plus 1.64 or 5. How different is what we saw from the president's claim? We saw 80, she said it's 50%. 50%, 1 minus 50% over 100, and we get 6 standard deviations. 6 standard deviations. 1 maybe, 2 maybe, 3 rarely, 6? We hit it out of the park. We crushed it. We're not only 95% sure, we're 99.99, probably a couple more 9s. You know, 6 sigma, you've ever heard of 6 sigma? You know, quality control? That's what? 3.4 defects per million, you know, so that's 0.00000017, something like that. You know, that's what we're talking about here. That's the chance that the president's telling the truth. You know? Yeah. So is 6 more than 1.64? Yeah, I mean, it's 3 times more. We reject HO. It is so huge a difference that, you know, we only went 3.6 standard deviations, and you know, so it's literally off the charts in our workbook. So we would conclude very conclusively that a majority of the students are in favor of this this proposal. Okay. So you've done a case of number 1 and a case of number 3. Let's try another different case. How about page 34, number 10? Allbrand is a product manager for a high fiber cereal called Fleet Flakes. Al has announced the release of the new improved Fleet Flakes with extra fiber. Sample of 100 boxes of the new cereal showed average of 109 grams of fiber with a standard deviation of 20 grams. We took a sample of 125 boxes of the old Fleet Flakes, and the average fiber there was 185 with a sample standard deviation of 25. So I have 2 sets of data, one from the new improved. What do we know? We don't know anything about the population, but took a sample of 100, got an X-bar of 190 and an S of 20. The old Fleet Flakes took a sample of 125, 185 for X-bar and a 25 for S. So what can we estimate from this? Well, I estimate that we're putting in, what, 5 more grams of fiber. Compare the 190 to the 185. I think the new improved flakes have 5 grams more of fiber. And I think we've improved our production process because we have less variability. So I think we're improving our production process is what I would draw from that. Well, can Al prove his claim at the 0.01 level of significance that the new Fleet Flakes has more fiber than the old Fleet Flakes? So Al wants to go on TV and have one of these ads that goes like this. Scientific testing in independent labs proved with 99% certainty that the new Fleet Flakes has more fiber than the old Fleet Flakes. That's what he wants to go on TV and say. And he wants hypothesis testing to provide him the means to do that. So what's HA? I'm trying to show that the average fiber in the new, in all the boxes of the new Fleet Flakes is more than the average fiber of all the boxes of the old Fleet Flakes. It's best in whatever order they're listed in the problem, keep them in that same order and let the first group be group 1 and the second group be group 2, sample 1 and sample 2. Okay, what's left? HO is the opposite of that. Was it greater than here? So what's the opposite? Less than or equal to is everything else is less than or equal to. So we're going to assume until we can prove statistically different that the new has the same or less fiber as the old. Then we go to our NIFTO handout. Which case is it? It's qualitative data. No, it's quantitative data. Just seeing if you were watching. It's quantitative data. 2 of you looked at me strange. The rest of you, I'm sorry I interrupted your nap. I'll try to talk softly next time. So we got 2, it's quantitative data, and we have 2 samples. One from the, kind of the experimental group and one from the control group. Now, it's not exactly that, but it's like that. And it's a case of 2A. Okay. Are both of them greater than 30? Yes, they're both greater than 30. The sample sizes of both is greater than 30. And which one are we trying to show? We're trying to show there. That was our alternative, that the new had more than the old. So this is a case of 2A3. 2A3. And anytime I'm showing a greater than, I'm trying to prove my outlier, my extreme case will be more than what they're claiming. So it's z-test greater than z1 minus alpha. And then here's the formula for how we get the number of standard deviations. The two are apart. Our observation from the new and our observation from the old leaf plaques. All right, so again, I just transcribed those across here. So we want to be very, very sure. We want to go on TV and say we're 99% sure. Now, scientific testing and independent labs prove with over 99% certainty that we're putting more fiber in our product. So our Z1 minus 0.01 is Z.99. We go to our tables here, say where's 0.99? Almost there, over here. Oh, okay, that's a pretty good one. 2.33 standard deviations of difference. I reached the 99th percentile. 2.33. All right, so I plug into my z-test formula. And I get it's 1.67 standard deviations of difference. Is 1.67 greater than 2.33? No. You have to accept HO. Or sometimes it's said reserved judgment. In a real court, this is referred to as case dismissed due to lack of evidence. Okay. This happens a lot in our court system. You know, people say we were found not guilty. Do most of the jury think they're guilty? Yes. But, you know, they say, I've been vindicated. No, you haven't. You were just not proven beyond a reasonable doubt. And as I said, juries cannot figure out what reasonable doubt is. All right, so we have to say, I can't prove it. Okay, we could go on TV with the p-value. Let's see what the p-value is. To find the p-value, we go down to where we ran our test. That's how we ran our test. What do? I put in the word p-value for alpha, and then I set it equal to whatever my z-test value was. So I get this. Then I go look up 1.67. 1.67 is 1.67. 1.67, here we go. 0.9515. That's it, right? Yeah. Oh, one more. There we go. Here, right. Here, right there. I got it. 0.9525. There it is. So we set that equal to 0.9525. Okay. And we set these two equal to each other. The 0.9592 equals 1 minus the p-value. Solve for the p-value, and we get the p-value is 0.0475. There's a 0.0475 chance that the new product is not better than the old. There's a 0.9525 chance the new product is better than the old. So we can go on TV and say we're over 95% sure our product is superior. But still, that doesn't sound as near as good as going, I'm 99% sure. What should L do? What should L do? If you were L, what would you do? Absolutely. Bingo. Take a bigger sample. What did our dear and beloved prof say? Bigger samples, more certainty. Yeah, knock it up to 200 each. You'll prove your case hands down. Take a bigger sample size. We have evidence that clearly shows we're right. We just need more evidence. Take and make it 400, and you'll be 0.001 maybe, 99.9% sure. Okay. If you want to get something published in an article in any kind of research journal, if you go on with 0.05, you're on very thin ice. So 0.01 is good, or 0.001 is real good. When you try to publish something in a research journal. All right, so we've done 3 of the 4 cases. Practice problems, page 34, number 11, 34, number 13, and 32, number 3 for Saturday. Ay, caramba, at 9 o'clock. Saturday, 9 o'clock, we will commence. Yes, sir.
Sample final test?
Sample final. I've been asked that a couple times. It worked out well for you last time. It wouldn't work out well for me at all last time because I didn't go over it with a fine-tooth comb. My first problem is I don't have a solution set worked up on a final yet because I don't return the finals. You don't get them back. I have to keep them. But I do a different final every time. It's not for a matter of me not making up a new final for you, which I will. It is if I feel motivated to write a solution sheet, because if I just give you an old final without the solutions, I'm going to be bombarded by people. So it's a no-win for me. Let me see what I can do. I won't promise it, but if I feel energetic between now and a week from today, which is our final, and they're really trying to get me. Next week is our final, right? Jeez. Short and sweet. All right, have a good rest of the weekend. See you on Saturday. I will also go over the demo of data analysis, which you need for the case study, and show you the last case study.